Welcome to another GCBASIC tutorial. This is for the PIC18FxQ35 family, but it applies to any of the microcontrollers, to be quite frank. The whole approach is extremely similar. This is part 11, and let's get started. So this is part 11 for I2C, TWI, I2C, I2, call it what you like, but it's all around discovering the parts attached to the board and to the microcontroller, obviously. So please like this video and subscribe. This is quite an important one. So we are over halfway through, which is great. So we're going to actually discover some I2C devices, and those I2C devices are attached to this board. So this is the board. A lot of red here, because I realized I hadn't been really updating this, because this board has 18, 28 or 40 pin. I'm using a 40 pin dip. It's got a regulator for voltage, and it's got RS232, which we've used. I've got a PIC kit hooked up to it. I have a serial connector for I'm using this serial connection. I've got a pop, 3 buttons, power, LEDs, and this time we're going to see, but we won't be using them directly yet, a 32K EEPROM via I2C, and there's a thermal sensor. We won't look at that this time. I think we will come back to that. I think it'd be interesting to do other bonus ones on this, and there's a clock and there's all sorts of things. Let me tell you what I've added now. Plus, I've added an I2C graphical LCD. Let's get into this. So look, this is the circuit that this is the reference circuit in the PDF, and I've actually highlighted some new sections, and those new sections are here and here, and these are I2C devices, but I've got another one attached. Let's look very carefully at those example circuits. These are the ports that I will be using. Here, RC3, RC4. They are called the SDA and SCL. We'll look at that in a moment. And they are both pulled high by 4.7K resistors. That is important, that they are pulled high. You could use the internal resistors inside a microcontroller. I don't. I need to know they're pulled high, and they are then connected into the SCL and SDA of the target device. The rest of it is the same. Critical, those are fitted to any I2C device. Let's go back to this chip. It has a VDDIO2, and that is applied. And let me go back to my pen, please. Sorry. Here, I'm applying voltage here because no VDDIO2 power, no domain IO. Because I am using RC3 and RC4, and they are in that same domain. So if I don't apply voltage to that VDDIO, it doesn't matter what my code says, I won't get any signals. Okay, so I'm making very clear. You've got your software installed, you've got your programmer working, you've got the chip, you've got the LEDs, you've got your party switches, USB TTL converter. One and more I2C devices are required for this. Now, this works. This is like an essential lifeblood to microcontrollers, because I2C uses a 2-wire open collector, open drain, pulled up resistors on the serial data line SDA and the serial clock line SCL. There is another one that we'll refer to later on in the tutorials, but those are the key acronyms: SDA, SCL. Typical voltage is 5 and 3 volts, but there are other voltages out there. Now, I've spoken about this in the other diagram. The pull-ups resistors here and here are being pulled up to the VCC, and I've attached in a little LCD through my blue wire, which is my SDA, and my yellow wire, which is the SCL. Now, what is important is I Well, for me, it's important anyway. I always use those colors. Let's have a look at the board to see what I've done. Oh, look at that. I've been zoomed in. I've been doing other stuff, by the way. Here we go. Look, there is a small LCD device here. By the way, this is very small. But look, I've got a blue wire and a yellow wire connected down to the RC3 and RC4. You can just about make it out, but just trust me, they are there. Also on this board is a thermal sensor here and an EEPROM device, all connected via the I2C bus. We'll come back to this later on. And so what we're going to do is we are going to go through an I2C sequence of a start, send an address, send some data, and then we'll stop. And we can test to see if a device responded. So we send a start, and it transitions those signal lines for you. You send an address, and if it gets an acknowledge, great, we'll put that away, and then we'll send some data out just to tidy up, and then we'll do a stop. Now, you can go and buy yourself devices that do this, but we might as well do it on here. So what we're going to do is we've seen this sort of hexadecimal table before. This is hardware. I'm going to show you hardware I2C, and essentially what we're going to do is send out an address to every single potential address. That's 0 to 254. Those are the total number of addresses, and we'll see if they respond. And we'll get a response from what's called the read address and the write address. So we're expecting to see some response. So we're going to go through, we'll look at the PPS, which is needed. We're going to use PPS for the serial, set up the I2C, and just review what happens. It's quite a nice demo, a really important one. So let's go to my desktop. I do not have it started, and I've got an icon now for the, well, I thought I had. GC Studio GCS, and it will start up. I think I've got an update on the system. So let me zoom in for you. I'm just going to take this 18F folder, or I should really do it properly. Vendor boards in your demo folder, microchip PICDEM plus board 2010 18F is what I've got selected. Select that folder. Zoom out. Let me zoom into the code here. Because I have been doing other work, I'll shut down this at the bottom, and then we'll just zoom in by pressing Control+. There we go, Control+. Now, what we've been working away here diligently, and we can see we have all these GCB source files. But we've also got, before I go down here, all the build folders, and loads of build folders, look, from all the other projects we've been working on. So I can go through and delete them all, or I can actually do it a bit quicker. Watch this. I can come into, well, I didn't mean to select a file. It doesn't matter if a file is selected, by the way, doesn't really matter. Function key F4, type in clear, clean solution. Oh, I do need a file open. All right, let me just select the one for the demo today. 170, show I2C devices to serial terminal. Function key F4, clean solution. What it's now done, look, if I cursor up here, it's cleaned out all the development folders. All the other build folders have disappeared. They've literally disappeared. This is all the presentations. It's gone. You can clear up, you can clean up, which is fantastic. So I've opened 170, show I2C devices to serial terminal. Let me shut that by Control B. Look at the code. We have selected the same chip, option explicit, no different from before. Well, the next thing we need to set up is the baud rate, because we're going to be using the terminal. We've seen that before. But now we've got a bigger PPS block, because we need to select a lot more things. So if we go function key F4, PPS tool will open up. It's just getting a list of the files, and then it will pop open for us, and I will zoom in, and I'll move it into view. So I've got my chip selected, and if we can remember back to the reference architecture that we put together, that we have TX1 serial out on RC6. I add that into my little list of code like that. Now I need to select the I2C. So that was the SDA1, SDA, not SDO, that's for something else, SDA1, and that's attached to where? RC4. I'm sorry, I just clicked on the wrong screen. RC4, I add that in. And then we've said quite clearly SCL1, which is its clock line, and we're going to have that on RC3. Is that correct? Let me just check what I put over here. Yep, RC3, add. And what we've got is a block of code here, which is identical to what's actually currently in the oh, I've done that wrong, look. I've got the clock lines mixed up, look. Oh, that would have been a disaster. It doesn't matter. That should be RC4, shouldn't it? SDA is on RC3. Well, at least you've seen it go wrong. Transmit, RC6. Now we should have something that looks like the one on the left, but we haven't. What have I done wrong here? I'm selecting the wrong lines, look. Let me clear and do it slowly. RC3. That's the SCL1. Click. SDA1. That's on RC4. Click. Transmit. RC6. Click. Now we should have the same as what's in my example. And it is. I can copy that, put it in my clipboard, go back to my desktop, pop that away, and just look, I can just take the whole thing and paste it in. So SCL is on RC3. Let me just look at my little diagram here. RC3 is the SCL. SDA is on 4. SDA is on 4. I think we're good to go. You have to set up the PPS. There is no way around it. The rest of that is all the same. Oh, I have a duplicate. Well, the rest of that's all the same. I've still got all the LCD set up. Doesn't really matter, doesn't it? And then we get into how do we set up the I2C? Well, we just define the hardware H I2C underscore data line. We know that's on C4, and the clock I2C underscore clock is on port C3, and then we give it a rate. I would recommend strongly that you use 100 for discovery. If you want something to respond, just keep it slow to start with. Then we have to tell it what mode it's in. We just say it's a master. I2 mode, master. Now, there are some optional things you can do on the Q35 chips. I've left them in there for documentation purposes. There is a buffer size that you can play with. It's just a RAM thing. And you can mute some warnings. And if you take those out, you can play with this on your own, okay? It just changes the amount of buffer that's available. And then all we're going to do is I'm going to ignore for the time being the variables, don't really need them. I'm going to send some serial stuff out, and I'm going to frame that output. But here's the essential lifeblood. Do a start, send a device ID out, and that's going to be between 0 and 255. Send out a 0, and that just prevents the read address from locking up. That's just required. And then you send a stop, and then you just test the result. And if the ACK poll state is false, we know it's there. So great. why don't we just bring up the terminal, F9, function key F9, where's it gone? I will bring it in over here. And we'll try and put it on the left-hand side of the screen. There we go. What font is that set to? Font 16, that's good. Function key F5. Let's just move all that to the left. Bring the terminal back. I should connect the terminal really, shouldn't I? Rescan, connect the terminal. I'm going to push the button on the board and it's done it. Look, I have got a device on 78 and 79. I know that. I've got a device on 9A and 9B. I know that. And 0, A0 and A1. Okay, that's incredible, right? Because it's done it. Because if this is the way to do it, there's no point of doing I2C TWI unless you've done a discovery. Now, what you can do, you can, if you don't believe this, I'm just going to put that back to default. I don't know why it's zooming in like that. Is you can go and buy, where is it? You go buy a device that does all this for you, and you can load the microchip software. Where is it? It's over here. Is that one? Is that one? I think that's one. Yeah, I think that's one. You can buy a device called an MCP something something something, and you can have a piece of software on your computer. Then you can run it, and it will do a discovery for you. Or you can just use your actual hardware, as I am now. And I'm going to find this device and show it to you. So this is it. Look, it's a little board you can buy from Microchip. You can get these off the internet, and it actually allows you to do a lot more discovery things in. There we go, right down there. MCP 22221A. But tell you what, nothing better than doing it on the actual hardware. Let's go back to the desktop, and I'm going to unplug. Let me go back here. I'm going to unplug this GLCD. Let me unplug it. I've unplugged it. Look, I have no idea why that's zooming in like that. And now let's just rerun the discovery. It's gone. If we look at that result, 7.9 has disappeared. Of course it has. 9A it's the next one along. I'll plug it back in though, just to prove what's going on here. I'm going to do this live. See if I can line it up with my best Mark 1 eyeball. RC4 is there. Plug it in. RC3 is there, and plug it in and push the button, and it becomes live. Do the same for every I2C device, so you get what you expect, and you'll be successful. Don't post on their forum if you haven't done this, because the first thing I will ask you is, have you done a discovery? Because it just proves the circuit is operating. In the next tutorial, we will fire up a whole series of I2C devices and have a bit of fun. So we're going to use an I2C GLCD device. Actually, I've got 3 of them to show. Yeah, 3. Just to show how the different parameters all work and their different characteristics. There were so many I2C GLC devices. I've just picked 3, okay? And they're all the same basic chip, but it just shows how things work. So enjoy.